So today we are gonna do Pearson Edexcel International A Levels May June 2025 paper code WMA11 or 1. Starting from the remaining questions, which is question 6. We did all the question 1 to 5 in the previous lecture. So here is the question 6. Yeah. The shaded area in figure 2 shows a plan view of a helicopter landing pad. Okay, this is a plan of a landing pad for a helicopter. The area consists of a major sector AOB, A to O to B. This is a major sector of a circle. Okay, and the other minor sector is, this is how it will look like if we will complete the circle. Okay, but we don't need that for now. Of a circle center O joined to the triangle AOC. So this is the triangle A to AOC. Given that OA and OB, which are the radius for this circle, as a 15 meter length. So OB and OC are given to be 15 meter each. Okay, since it's the radius, so they will be equal. BC is 2. This extra part coming out of the circle is BC, which is a length of 2 meter, an extra. Okay. CBO is a straight line, CBO, that makes it up a straight line of total length 17 meter, as you can clearly see, and angle ACO is 0.6 radians. ACO angle. Okay, how do we get ACO angle here? ACO, this is the angle which is 0.6 radians here. What we have to find, part A, show that angle COA is 847 radians to the 3 decimal places. COA. This is the angle we want to find out. Okay, the blue one. Okay, and we want to angle O, prove it equals to 1.847 radians. Right. We will be just looking at the triangle AOC first, as we know one of the angle. And we are given the lengths as well, that is 15 and 15 each, so that you can clearly apply cosine or sine tool here to get the angle. Okay, first of all, what we're gonna do, let's find the angle CAO. Okay, we will find CAO angle first, and for that purpose we are gonna apply the cosine rule here, sine rule here. Okay, because you are given two lengths and the angle opposite to the given length is unknown, so you can easily find that. Okay, I'm gonna mention it as angle A. Okay, so I'm gonna apply the sine rule, which says that part A is, you will apply sine of A over the opposite length. Sine of A, the opposite length is 15. Sine of the angle divided by the opposite length, which is 15. So the proportion of the sine of the angle to the length is equal to the proportion of the other sine of the angle and its length. So the other angle and side is given. So sine of 0.6 divided by the opposite length, which is 15 here. Okay, so we're gonna write it 15. Okay, so we can simplify it and get the value for sine of A first. This 15 in division, when we will move it to the other side, it will get multiplied. Sine of 0.6 over 15 times 15. Okay, and you know, since you want to find the angle A, which is inside the sine, so you move the sine to the other side as well. That makes it so angle A stays here, and sine inverse, the sine other side becomes sine inverse of this whole thing, which is sine of 0.6 over 15 times 50. Okay, we're gonna do it on calculator. You can just simply put the whole thing in the calculator. So you put shift sine, you got the sine inverse. Now you do fraction sine of 0.6. Okay, you make sure your calculator should be in radian mode, since the angle given are in radians. Okay, so yes, it is already in radian, and sine of 0.5 bracket close, you times it by 15. Okay, come down, divide it by 15. Okay, oh no, wait, I made a mistake, sorry. Let me show you. Sine A over this total length, sorry, this total length is not 15, this is CO, you're getting the whole length, which is 17. Okay, CO is 17 in total. Okay, so it is sine A over 17 basically, and you will times it by 17 then, and it's gonna be 17 here. Okay, now we insert it in the calculator. First I need to go up and fix this 15. So here, yeah, and you done inserting the whole values in the calculator, bracket close. Now press equal. You got 0.6944. Okay, so the angle A is 0.6944. okay, this is the angle A you have got. Let's move up and show you where the angle A is. Okay, so this angle A is 0.6, what was that, 944. okay, 6944. But they ask you in part A to calculate COA, which is the pink angle here. Okay, angle at the center subtended by that triangle. So you know the sum of the total triangle is 180 degrees, but right now we are taking angle in radians, so we will take that 180 as pi. So now to find the remaining angle, you will just subtract the other two angles from pi. So 0.6944 minus 0.6. okay, so I will subtract these two angles from pi in order to get the third angle. Okay, so 0.6, you have 0.6 here. Now we'll insert it. So this is how you will get angle COA. okay, I'll just do pi minus 0.6944 minus 0.6. okay, so we got 1.84719. okay, but you have to round it up till, let's go back to the question. You have to get the answer till 3 decimal places. okay, so yeah, till 3 decimal places. These are your first 3 decimal places, so it will be 1.847. since after 7 you have 1, you just keep it as it is. So this is the required angle. okay, now part B. Part B says find the total area of the helicopter landing pad. We want to give your answer in meters square to 3 significant figures. We want to find the total area, this total area here. okay, so to get the total area, one of the things you are given is the triangle, right? You can get the triangle area. Go back, you can get this triangle area. okay, first let's calculate the triangle area, and then you can get the you can use the area for a sector. This is a major sector. okay, the blue one, this makes a sector of a circle, but for that purpose you should know the angle subtended at the center. So I think you can get the red angle, since you already know angle at O is 1.847. okay, so the angle you know, in the major sector, the red angle will be, the total circle is of 2 pi, so you will do 2 pi minus 1.847, which will make it 2 pi minus 1.847 as 4.43618. okay, 4.43618. we are not rounding it up. okay, now let me write the area for the sector formula, since this thing makes the area. okay, this is the this is the sector now. This whole thing is a sector, major sector of a circle, and we already know the formula for that. So area for the sector, that's the part B. Area of sector of circle is half r square theta. This formula will be used when you are taking angle in terms of radians. okay, so I will do half times r. You know the r already for the circle above, which is 15. okay, it is mentioned OA and OB is 15, so half times r, which is 15 square, times theta. Theta subtended at the center of the circle by the radii, which is 4.43618. okay, 4.43618. okay, now we can insert the whole thing in the calculator. You will get half times square of 15 times 4.4 3618, okay, and you will get it 499.07, okay, 499.07 meters squared. This is the area for the sector. Area of sector, what was the sector? It was AOB, okay. I'm just gonna mention AOB, right? Now we find the area for a triangle, okay. Next thing we find area of a triangle. You know that area for a triangle is half times AB sine theta. So we are given the AB length and the theta between them already. So these are the AB lengths we'll be using. This length is 17, this length is 15, and we know the angle between them. Okay, let me erase the rest. And we know the angle between them, which is 1.847. Okay, I'm gonna erase this. I know the two sides and the angle between them, which is 1.847. So I'm just gonna substitute them into this formula for a triangle. So this is gonna be half 17 times 15 are the lengths of the triangle, and the angle between them is 1.847. okay, now we insert it into the calculator. Half times 17 times 15 sine of 1.847, that gives you 122.6674. okay, that's the area of triangle. What was the triangle? It is AOC. okay, that is AOC. Now we get the total area, which will be area for the sector plus area for a triangle. Okay, to get the total area of this whole helipad, we add the area for a sector into area for a triangle. Okay, so that becomes where is that? 499.07 499.07 plus 122.66745, and it will get you plus, I'm just gonna add 499.07. I should have used the other figures as well. So that is 621.73745. okay, that is the area, but since they said in meter squared, the unit per length you are using is meter. They said in part B, get it till 3 significant figures. So my first 3 significant figures are 621, and after 1 you have 7, so that becomes 622 meters square. okay, that is the area, right? Area of helipad. okay, or you can say the shaded area. okay, now the part C is, yes, I have space to cover that part C as well. okay, part C is find the perimeter of the helicopter landing pad. okay, give your answer in meters to 3 significant figures. Now we have to find the perimeter of this whole shape, which is gonna be this total length here. okay, A to C, this 2 centimeter, and the arc length of the sector of a circle we are using. okay, we need this whole pink length. So first of all, let's calculate the arc length of this sector of a circle. okay, this sector of a circle. So we'll do arc length of AOB. okay, AOB arc length. So arc length for AOB, you know that the arc length is r times theta. So you know the radius of the circle segment, I mean the sector, which is 15 times theta, the angle made by that arc length. So angle made by this pink arc length A to B is 4.43618. Okay, so 4.43618, I'll just 4.43618 times 15, which will get you 66.5427. 5427. You don't round up the numbers right now, just round up the whole answer, okay? Otherwise there will be the difference in the answer. Okay, this is the arc length. Now we get now let's get the AC length. Okay, in order to calculate AC length, you are gonna use a triangle, and you know that this length is missing, but you are given the angle opposite to that length, and you are given the other two lengths as well. Okay, CO and AO. So we are gonna use the cosine rule here. What does the cosine rule says? Let's apply the cosine rule to the triangle. Okay, so the missing length, let's say, is x, AC length. Okay, or I'm just gonna write the AC here. AC squared equals to the sum of the squares of the other two lengths, which is, for this triangle, which is 17 and 15. Okay, so I'll be writing 17 and 15. So 17 square plus 15 square minus 2 times the same lengths, which is 17 and 15, and the cosine of the angle opposite to the side you are using here on the left hand side. Okay, which is angle opposite to AC length is 1.847. Okay, so 1.847. You do not exceed this boundary. I'm writing a little bit bigger, so I'll try to write small now. So AC squared is equals to, I just put the whole thing in the calculator at once. So 17 squared plus 15 squared minus 2 times 17 times 15 times the cosine of 1.847. yeah, and that is the square thing. You have got 653.0796. 653.07964. But we need just AC, we don't need it square, so we will square root on both sides. And now when we square root the answer, it gets us 25.5554. okay, so this is the AC length. Now the perimeter for the whole shape will be the arc length for the circle, which we got at 66.5427. 66.5427 plus the AC length, which is 25.5554. 25.5554 plus, we are not done yet. Okay, I'm just gonna erase it now to show you. Okay, I got this arc length value, and then I got the AC value, but there, since we have to calculate the perimeter for the whole thing, we need this CB length as well. Okay, to get the perimeter for the whole figure. Okay, so this CB length is 2, you know that, so I'm just gonna add 2 as well, so plus 2. okay, we'll plus 2 here. Now add them all. Okay, we already got that figure here, 25.5554. now I'll add 66.5427 plus 2. okay, so I got 94.0981. 94.0981. okay, meters in length. So the perimeter is this, but we have to round it up. Look at the question. We have to round up till 3 significant figures, which will be, okay, after 0 you have 9, so that becomes 94.1 meter. Okay, so this is the perimeter for the whole figure above. Okay, we are done with question 6. Let me show you, it was a bit lengthier one, and let me show you as a whole. This is the whole question number 6, which is worth 9 marks. Okay.